Hello, my name is Danielle Cook, and today I'll be sharing a story of NASA's bio-inspired acoustic absorber, an inventive journey towards peace and quiet. I'm an aerospace engineer in the acoustics branch at the NASA Glenn Research Center. I'd like to say that our mission is to help create a quieter world by researching ways to reduce aircraft engine noise pollution, and our vision is to help create a more peaceful world by bringing out the best in each other through creativity and curiosity, competition and collaboration, communication and compassion. It's good to be with you during Biocene 2022 as we consider the transformation of transportation, and we encourage everyone to think about using multifunctional acoustic absorbers to help us reach that destination. We are asking, how might we develop a commercial air transportation system accessible to a growing population that's safer and cleaner and quieter than the one that exists today? We know many types of flight vehicles are in service today, with many more exciting concept aircraft and prototypes of every size, shape, and speed developed every year. We know we will still need to integrate acoustically absorbent liners into aircraft engines and fuselages of all types for the foreseeable future. Aircraft engine liners are used in turbofan engines today. The next time you have a chance to ride on an aircraft, take a look inside the engine. Sometimes you can see these liners placed upstream of the bypass fan. The liners absorb sound from inside the engine before that sound has a chance to propagate to the ground and be perceived as noise pollution. If you could see under the perforated surface of today's aircraft engine acoustic liners, you might see one or more layers of honeycomb. Perforated over honeycomb acoustic liners are resonant structures that can survive the harsh engine operating conditions during flight and absorb sound. Melamine foam is another kind of commercially available acoustic absorber. These lightweight porous structures tend to absorb water and oil and are not durable enough for aircraft engine noise control. While both styles of acoustic absorbers are impressive, neither are perfect. We were recently inspired by the acoustic absorption of bundles of natural reeds, tall grasses that grow in wetlands across the world that people have used for millennia. NASA is asking an engineering question: how might we create thin, lightweight, multifunctional structures to transfer heat, carry load, and absorb broadband noise, especially below 1,000 Hz, while also surviving the harsh operational conditions such as exposure to sprays of liquid and solid debris and high temperatures? Proof-of-concept tests performed at NASA have demonstrated that additively manufactured synthetic structures that resemble the bundles of natural reeds offer an increase in sound absorption below 1,000 Hz as compared to the state-of-the-art commercially available structures like the perforated over honeycomb liner and the melamine. You can see in this graph of acoustic absorption coefficient versus frequency that the natural and synthetic reeds are doing something different below 1,000 Hz, and we believe that in the age of additive manufacturing we could exploit this difference for hopefully a useful purpose. If you think that this technology has future on board an aircraft, know that there are a variety of test rigs and facilities available at NASA to help mature that concept. NASA cannot do this alone. In 2021, the BioLiner was one of 12 technologies from federal and university labs selected for the virtual FedTech Startup Studio, which was a technology transfer workshop. Federal inventors shared information about their patented technology with entrepreneurs. Entrepreneurs volunteered 20 hours per week in exchange for information about lean startup principles, the basics of licensing from and partnering with the federal laboratories, and the ins and outs of the SBIR, STTR programs. Entrepreneurs drafted business plans and conducted customer use surveys to assess the commercial potential of the patented technology. The FedTech Startup Studio ended with a virtual pitch day event. Entrepreneur teams presented their business plans to representatives from the federal labs, the FedTech staff, and an investor panel. Deliverables to NASA included a final report and copies of the Entrepreneur Pitch Day videos. FedTech judged the entrepreneur pitches this year, and the winner was offered some continued support as they tried to form new companies and license technologies from the laboratories. NASA Glenn's Tech Transfer Office is available to answer your questions about licensing NASA technology, using NASA software, accessing NASA facilities, and working with subject matter experts from NASA in a variety of partnership arrangements. I know the Biocene audience is excited about educational outreach. Know that there are several online resources available related to this technology, including an Exploration Nature Knows Best video interview, high school capstone projects, and a leveled reader series from NASA ARMD. In conclusion, NASA's bio-inspired broadband acoustic absorber, the BioLiner, is patented technology that can be developed into multifunctional structures that can absorb sound and carry a load and also transfer heat. BioLiner was one of 12 technologies from federal and university labs that was selected for the FedTech Startup Studio in 2021. Results of that investigation supported the claim that the BioLiner might have broad commercial potential beyond aerospace use. And the Startup Studio was just one way that the NASA Tech Transfer team is reaching out to entrepreneurs. I'd like to acknowledge the growing team of researchers at NASA Glenn and NASA Langley and the funding that we've received from NASA's AATT project and the T2X project to perform this work. I'd like to thank you for your attention.